Annuities, loan repayment. Future value of an ordinary annuity. If R dollars are contributed at the end of each period for N periods into an annuity that pays interest at rate I at the end of the period, the future value of the annuity is S equals R times the quantity of 1 plus I to the N minus 1 all over I dollars. Example 1. Future value of an ordinary annuity. Find the 5-year future value of an ordinary annuity with a contribution of $500 per quarter into an account that pays 8% per year, compounded quarterly. We'll be using the formula above. Let's list what each thing is. Our R is the dollars contributed at the end of each period. R here is $500. Remember that I is 0.08 divided by 4 because we have 4 periods in that year, and that gives us 0.02. And N is the number of times it's compounded. We're compounding quarterly, which means 4 times a year, and we're investing for 5 years, so that's going to be 20. 4 times 5 is 20 times that it's compounded. Let's go ahead and put this all in the formula. S is 500 times 1 plus 0.02 to the 20 minus 1 divided by 0.02. Let's go ahead and put that into our calculator. We have 500 times, open up parentheses, and if you want you can use the fraction template. That'd be 1 plus 0.02 to the 20, arrow right, minus 1, arrow down, and 0.02, close your parentheses, and we get a future value of $12,148.68. So contributing $500 every 3 months into an account that pays 8% per year, compounded quarterly for 5 years, you'll get $12,148.68 as your ending balance. Present value of an ordinary annuity. If a payment of R dollars is to be made at the end of each period for N periods from an account that earns interest at a rate of I per period, then the account is an ordinary annuity and the present value is A equals R times 1 minus 1 plus I quantity to the negative N all over I. Example 2, present value of an annuity. Suppose a retiring couple wants to establish an annuity that will provide $2,000 at the end of each month for 20 years. If the annuity earns 6% compounded monthly, how much must the couple put in the account to establish the annuity? So let's first start by identifying what our variables are. So that is the payment that the couple wants to have at the end of each month for 20 years. That's the $2,000. I is the interest rate per period. So we have 6%, which is monthly. So we're going to take 0.06 and divide that by 2. Sorry, divide it by 12. And so we get 0.005. Okay. And N Again, N is the number of periods. So and next we need to find the value of N. N is that they are going to want payments for 20 years monthly. So 20 times 12 is 240. Let's go ahead and set this all up in our formula. A equals 2,000 times 1 minus 1 plus 0.005 to the negative 240. That's all over 0.005. Let's put that into our calculator here. 2,000 times parentheses. We'll use our fraction template. 1 minus 1.005 to the negative 240. And that's divided by 0.005. And so the annuity needs to be $279,161.54. And that will give them an annuity that provides that $2,000 at the end of each month for 20 years. Example 3, home mortgage. A couple who wants to purchase a home has $30,000 for a down payment and wants to make monthly payments of $2,200. If the interest rate for a 25-year mortgage is 6% per year on the unpaid balance, what is the price of a house they can buy? So again, we're going to use this formula. R is the 2,200. It's going to be paid monthly. I is the interest rate per, so we have 0.06, and that is paid monthly. So we're going to divide by 12, and so we get 0.00. And our N is the 25 years times monthly payments, 12 monthly payments. So 12 times 25. We're going to have 300 payments. So let's go ahead and put our formula all together. 2,200 times 1 minus 1.005 to the negative 300, all divided by 0.005. Again, we can put this into our calculator. We have 2,200 times parentheses. Let's use our fraction template. 1 minus 1.005 to the negative 300, and that's all over 0.005, close parentheses, and we get an amount of $341,455.10. So that is the price of a house that they can buy given these constraints. Amortization formula. If a debt of $A with interest at a rate of I per period is amortized by N equal periodic payments made at the end of each period, then the size of each payment is R equals A times I over 1 minus 1 plus I quantity to the negative N. Example 4 uses this formula. A couple wants to purchase a home with a price of $230,000 has $50,000 for a down payment. If they can get a 25-year mortgage at 9% per year on the unpaid balance, what will be their equal monthly payments? What's the total amount they will pay before they own the house outright, and how much interest will they pay? Let's first start by finding the equal monthly payments. So let's first start by finding the amount that they need to borrow, which is going to be their debt A. They have $230,000 house they want to purchase, and they have $50,000 for a down payment. So A is the amount of the debt. They have a house they're looking at that's $230,000, but they have a $50,000 down payment. That means that they're going to need to borrow $180,000. I is the interest rate per period, so that's 0.09 over 12. So we can put this into the calculator if we want, and that gives us 0.0075, and N is the number of equal payments. So we'll have 25 years of monthly payments. That again is going to give us 300 payments. Let's put this into the formula then. R is $180,000, and that's times I of 0.0075, all divided by 1 minus 1.0075 to the negative 300. Yeah, let's put this into the calculator. 180,000 times, we'll use our fraction template, 0.0075 divided by 1 minus 1.0075 to the negative 300, and that is going to give us $1,510.55. So that is your monthly payment for the purchase of this particular house. What's the total amount they'll pay before they own the house outright? Well, we're going to take that payment, the $15,000 or $1,510.55. They are making 300 of those payments, so they're going to have $453,000, 100, so $453,165 even is the total amount that they're going to pay before they own the house outright. So how much should they end up paying in interest? We can take that amount, subtract off the amount that they originally borrowed. They are paying $273,165 just in interest. Quite a bit. And that does it for this section of homework. Go ahead and start your homework. Let me know if you have questions.